Hello, this is Harry, and this is Phys2lab1 charge tapes. In this experiment, I observed the interactions a negatively charged piece of tape had with other objects. The first piece of tape, through friction, transferred electrons to the other pieces I made, polarizing them. Because of this, I was able to observe the attraction force between the tape and objects. I also observed the repulsion force from both charged pieces of tape while in close proximity. Some of the key concepts in this lab are the interactions between atoms, Coulomb's law, polarization, and the relationship between electric force and field. And these are some important formulas. Assumptions. Both pieces of tape have the same mass, both have the same charge. Tape is treated as a point with all the charge centered there. Force from air resistance is ignored, and gravitational force is equal to the electric force because the net y component of force on the tape is 0. So the length of the tape was around 8 inches, which is about 0.2 meters. The mass is 0.0002 grams. The distance between the two tapes is 0.02 meters. The charge of the piece of tape was around 9.33 times 10 to the negative 9th coulombs. And I found this by equating Coulomb's law to the gravitational force formula, which is mg, and solve for q after plugging in the mass and distance. For Coulomb's law, since both pieces of tape had the same charge, it would just be q squared. The magnitude of the gravitational force was 0.002 newtons. The magnitude of the electric force was 1.961 times 10 to the negative 3rd newtons, which I found after plugging in the charge of a piece of tape. In my computational model, I initialized the K constant, the charge of a proton, the mass of the tape I calculated, the y component of the distance between the two tapes, and the charge of a piece of tape. And I'll show it right here. So this is my code. This is where I initialize most of everything. So I solved for electric force using Coulomb's law over here. And the gravitational force is the opposite. It's like negative because it's in the opposite direction. And this is for the electric force on tape A due to tape B. So it's also in the opposite direction, so it's negative as well. This is how the model looks. The purple arrows represent the electric force, the blue arrow represents the gravitational force. And these are the values that I got. So what if? I don't believe anything significant would change from my observations if like the charges were switched. Even with the positive charge, the electrons in the tape would still transfer. The tape would still attract other objects and repel the other piece of tape. The only thing that would be different is that the tape would be positively charged with electrons instead of negatively. Why? I believe it is important because when your hands make contact with the charged tape, the electrons could be transferred to your hand, then polarizing it. Then the tape will have less of a negative charge. Yeah, that's about it.